StackGuard is a compiler extension that enhances the executable code produced by the compiler so that it detects and thwarts buffer overflow attacks. StackGuard prevents active changes to the return addresses by detecting the change either before the active function returns or by preventing write to the return address. While StackGuard is described as a compiler enhancement for protecting stack return addresses, it is often used to prevent privilege escalation for many potentially vulnerable programs. Without StackGuard, we can see that when attacker provides a sample which overflows the buffer, it modify the EIP instruction pointer. To protect from modification of EIP, now a canary word is put on the stack in between the function s local variables and saved EIP. If a local buffer is overrun, the canary will have to be killed before the saved EIP can be modified. Before function returns, checks whether the canary is still intact. If not, hand program control to a predefined exception handler and terminate the program. There are three types of canaries: terminator canaries, random canaries, and random XOR canaries. Terminator canaries detect runaway strings, but is itself a known value, composed of 4 different string terminators: carriage return CR, line feed LF, null -1. It is based on the observation that most stack smashing operations involve string operations, not memory copy operations, which almost always apply to heap-based objects. Hence, any memory copy will be able to overwrite the terminator canary value. Random canaries detect all sequential writes that do not know its secret value. It's based on the assumption that the exploit can sequentially write any value it wants and keep going. So it forces the exploit to know a 32-bit random number retrieved from a global variable that is initialized to a different value each time the program executes, similar in a way to address space. Layer randomization, ASLR. The global variable has to be write protected, but if an attacker can deploy an exploit that reads the canary value from any location in memory, both string and memory copies can easily overwrite the correct value. Random XOR canaries are random canaries that may also detect random access memory writes into the protected region. In addition to employing the random canary defense, some of the saved control information is XORed or encrypted with the random canary value, and the result is stored in the canary location. However, an attacker can change the control values by deploying an exploit that sets the canary location to the XOR of the random canary value and the new control values used in the encryption. In addition, it is also susceptible to string and memory copy. This is the type of canary used in StackGuard. It is unsafe to write the copy data provided by user directly to the buffer. Instead, using pointer to address the buffer is better choice. Stack smashing attack attempts is a form of vulnerability where the stack of a program or system is forced to overflow, also called buffer overflow, which could lead to program crash or subversion. The stack may be corrupted in such a way that executable code is injected into the program, which when run could allow an attacker gain unauthorized access to a computer. Most buffer overflow exploits attack buffers allocated on the stack to achieve 2 things. Inject attack code. This is done in many cases by providing an input string that contains a binary, executable code to do something, e.g. exec sh to produce a root shell. Change return address. The stack frame for the currently active function, which usually contains the return address, the location the program returned to when the active function completes. Alternatives to GCC's StackGuard have been implemented on other platforms. 2. Noteworthy mentions are OpenBSD, Propolis, and Microsoft Visual C.NET. Stack guard prevents changes to active return address in two ways. By detecting change of the return address before the function returns. More efficient and portable. By completely preventing the write to the return address, more secure. Detecting changes to the return address, integrity checking. For this to be effective, check must be done before the function returns. Stack guard achieves this by placing a canary named after the Welsh miners. Canary, used to detect air pollution due to its high sensitivity word next to the return address on the stack. When the function returns, the canary word is checked to see if it is intact before jumping to the return address. Because buffer overwrite can only occur in a linear direction depending on the stack growth, the canary is placed in such a position that the return address cannot be altered if the control value, the canary word, is not altered. If the attacker can easily guess the canary value, then it can be placed in the correct place so the attack proceeds as expected. Also, if the canary value is static, then it becomes very easy to guess. In order to deal with this, randomly shows as canary values are used. Preventing changes to the return address bounds checking. This is the more secure and ultimate way to eliminate buffer overflows, but the peculiarity of the C language make it difficult to provide fully secure array bounds without insignificant impact on performance. Stack guard uses MEMGuard, a tool which provides memory protection in such a way that individual words of memory can be designated as read-only, except when explicitly written via its API. MEMGuard prevents buffer overflow by protecting a return address when a function is called and unprotecting it when the function returns. This is made to occur in the same places as the canary word placement and checks occur, leaving only a slim chance for a buffer overflow to go undetected by both mechanisms canary and MEMGuard. Functions argument control. In standard compiled C code, functions arguments are located in the stack in higher addresses than the return address, which is after the saved frame pointer, which is always after local variables. Attack can bypass canary because arguments are used inside functions and check is made after the function has finished. 2. Returning with altered frame pointer. The default for stack guard is to use a terminator canary, a XED value of 0x000F0D. With common string operations it's not possible to write past this canary, but it's possible to write up to the canary, without altering it, actively gaining full control of the frame pointer. 3. Pointing caller s frame to GOT. This is most complicated way. In standard compiled C code, when not using FOMIT frame pointer, all local variables are accessed relative to the frame pointer. Then, if we have full control over it, we can choose where in memory local variables are placed. This is the trick used. Here, the address of message is relative to the frame pointer. As we totally control eb, we can force printf show us anything from memory. References are shown in this SILD. Thanking you watching this presentation.